We are going to be graphing. That wasn't what you're supposed to do. Okay, first thing we're going to do is just talk about how to recognize sine. We're not going to be graphing sine, cosine, and tangent all in the same graph. It's only sine, or it's only cosine, or it's only tangent. It's just one at a time. So, when we have the unit circle and we are talking about sine, we are talking about which of the ordered pairs it is the sine is the y. So at this first ordered pair at 0 degrees, what is the sine value? What is the y? 0. Then at pi over 6, our y value is, our y value, by the way, this is where I'm using color. Our y value is the up and down. The y value is how much at pi over 6, which is 30 degrees. Sine at 30 degrees. 1/2. It's a half. Thank you. All of you. All right, and then at pi over 4, that's 45 degrees. Sine is, y is, sine is square root 2 over 2. Then at 60 degrees, or pi over 3, sine is radical 3 over 2. Remember, we're getting bigger. And then at 90 degrees, sine is 1. So we're gradually getting bigger until we get to 1, and then after we get to 1, we go to the next angle over, which is 120 degrees, which is 2 pi over 3. Now sine is, what is it? It's radical 3 over 2. That's right.
Yeah.
But not negative. And then we get to 3 pi over 4, that is a 45 degree reference angle. What sine? Radical 2 over 2. And then we get to 5 pi over 6, that is a 30 degree reference angle. Sine is a half. And then we get to pi, which is 180 degrees, and sine is 0. Do you see how they're symmetric? Okay. So the sine value is getting larger all the way to 1, and then it's getting smaller to 0. But we have more angles around the circle. So once we get to 7 pi over 6, at 7 pi over 6, sine is the same distance as 5 pi over 6, except it's down, so sine is now negative a half. So starting at 0, we're getting bigger to 1, then we're getting smaller to 0, and then from there we start getting negative. We get negative a half, and then what's our next one? Negative square root 2 over 2. And then negative square root 3 over 2. And then negative 1. So we're getting more negative until we get to 270 degrees, or 3 pi over 2, that's negative 1. And once we get there, what are our y values doing? The y is just the length of this red line, like what's happening once I get past 270 degrees, what's happening to the length? It's getting closer to 0 again. So we've got, this one's going to be negative square root 3 over 2, negative square root 2 over 2, and then negative half. And then once you go to 0 and we go on, it repeats the process again. It gets bigger, then it gets smaller to 0, then it gets negative, then it gets closer to 0, then it gets bigger, then it gets closer to 0. What?
Does that say negative radical 2 over 2?
No, but it should. No. What?
Oh, never mind. My bad.
Sorry. Okay, so what is happening is we're going to take this and we're going to use this as an equation where f of x, the function at the value of x, is equal to the sine of x. X is the theta. angle. So our function, we're going to know the angle, and then our y value is going to be the sine at that angle. So that's going to be our ordered pair, the angle, comma, the sine. So in this chart here, if I wanted to know if the angle is 0 degrees, what is the sine at 0 degrees? 0. Pi over 2, what is the sine at pi over 2? 1. Pi, what's the sine at pi? 0. 3 pi over 2, what's the sine at 3 pi over 2? And 2 pi, what's the sine at 2 pi? So what I've done is I've listed key points. Those are the quadrants. There is stuff in between which we have on the graph. There is stuff in between which we have on the graph, but the key points are the extreme values and the middle values. You'll see when we put it on the graph. They're going to be the extreme values and the middle values. So we're going to graph these key points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Okay? And just this time, for assistance in graphing and seeing what this graph really looks like, we're going to also graph the pi over 4 values. Don't have to do this step every single time we're going to do it because it's the first time we're graphing this. We're going to find those pi over 4, the 3 pi over 4. I'm just going to look at the graph up here at the circle part, the unit circle. At pi over 4, what was my sine, my y value of pi over 4? Pi equal 2 over 2, which when you type in the calculator is approximately 0.707. So at pi over 4, I'm going to go to approximately 0.7. And then at 3 pi over 4, it was also the same number. It was positive 0.707. And then at the next pi over 4, it was in the third quadrant, so it was negative. And then at the fourth pi over 4, it was also negative. So you're going to carefully and smoothly curve this. You're going to curve it. I have to stand right in front, or mine turns out really bad even when I stand right in front. But I'll move as soon as I get it graphed. A smooth curve. But it does not stop or start at 0, 0. It does not stop or start at 0, 0, because on the unit circle we could go to negative pi over 2. What is it at negative pi over 2? Negative 1. What is it at negative pi? 0. What is it at negative 3 pi over 2? Negative. And then at negative 2 pi, it would be at 0 again. The pattern should continue. Okay. So before I connect these, never mind. I'll just highlight this part over here after I connect this, so I can talk about it. So the part I've highlighted is one cycle of this sine graph. A cycle would be one complete time around the circle without any repeats. This would be a complete cycle. This is what the sine graph looks like. Yes.
So only the highlighted part is the cycle?
That's one cycle, but the cycle repeats indefinitely, like forever, infinite. Infinitely. It repeats forever, okay? So this is one cycle, and that one cycle has a vocabulary word. See if we can think of a way to remember that one cycle is a period. Okay. Not joking, it's what it's called. So one complete cycle is a period. The whole thing you're going to be graphing, but you need to know what one cycle is. There's another vocabulary word we're going to be talking about again and again, and it's called amplitude. What is that speaker called when you plug your electric guitar in? Amplifier.
Fire.
But what's it do? It like amplifies it. It makes it louder. So the amplitude has to do with how high up and how far down these curves go from a midline. The amplitude is how high up and how far down these curves go from a midline. So for here, our midline would be the x-axis would be y equals 0. That's our midline. Our amplitude would be the highest point and the lowest point above it and below it. So how high up does this graph go? 1. And how far down does it go? 1. So our amplitude is 1 for this. Our period, I didn't actually put a value with that. Our period is from left to right, how much time it takes for this one cycle. Or it's not really time, but from 0 to the very end of it, 2 pi, how long is that? It's 2 pi long before it starts repeating again. It's a length of 2 pi. All right, when you got that down, turn the page. Let's do cosine. All right, so for cosine, cosine is always the which of the two? It's always the x. So when I look at this and I go to my first order pair, my x value is this length. My x is what? 1. And then my second one, my x value is what is the cosine at 30 degrees? Louder.
Square root of 3 over 2.
Square root of 3 over 2. And then at 45 degrees, square root of 2 over 2. And then at 60 degrees, 1/2. Follows the pattern. And then at pi over 2, what's the x value? 0. We start out at 1, and then we get smaller to 0. Then once we hit 0, what happens to my next x value at 120 degrees? -1/2. Then negative square root of 2 over 2. Then negative square root of 3 over 2. And then we've got -1. So if you're using colors, I made my positives and my negatives different colors so we could see. Then once I hit -1, my next amount is shorter than -1. So we're getting closer to 0 again. This is negative what? This amount is negative square root of 3 over 2. And then we're getting closer. Negative square root of 2 over 2. And then we're getting closer to 0. -1/2. And then we're at 0 again. And once we hit 0 again, then we go back to positive. +1/2. Then positive square root of 2 over 2. and positive square root of 3 over 2, and then back to 1, and then we go down again. And then we go negative again to negative 1, then we go up again. And it continues and continues. All the numbers are the same for sine and cosine, they're just in different order. Starting point, but they're the same. Let's do some key points. Key points, cosine at 0 degrees, or 0 radians, is 1. At pi over 2, 0. At pi, negative 1. At 3 pi over 2. And at 2 pi. So we're going to graph those. And we're going to also graph the pi over 4s just this one time, just to give us a nice picture. You don't always have to graph the pi over 4s, but it's the first time in class we'll do it. So I'm going to graph 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. I'm going to put in my pi over 4, which which are the square root of 2 over 2. Which is approximately 0.707. So at pi over 4, it's 0.707. At 3 pi over 4, it's negative. And we got another negative, and then we have a positive there. This is one cycle. What's the cycle called? This is one period of cosine. But you don't get away with just drawing one period. You have to continue the pattern. So I'm going to continue the pattern to the left until I've filled up the whole graph. But I'll highlight the one cycle so we have an idea of what cosine looks like to begin. And then the arrows at the end mean it goes on forever. So make sure you have arrows at the end. One thing I see people do wrong often on cosine. So this is wrong what I'm about to do. This is wrong. I see this happen all the time. Because they like are going up, but then you don't think about what's next. The next thing would be down, so at least curve your arrow down. So for cosine, for this parent function, what is our amplitude? So remember the amplitude is how high up and how far down from the midline this graph goes. It goes all the way up to 1, it goes all the way down to negative 1, so the amplitude is the distance 1. And then the period, one cycle currently for the parent function is 2 pi. So you guys remember we had parent functions many times in this class. So what do we do after we have parent function?
Stretch,
We stretch, we shrink, we translate them.
we make children hate them more.
Yeah, I guess, or understand them more. So make your pre-calc and calculus years a lot easier. You understand it better. Okay. So this is not written in there. If you want to write at the bottom of that page before, there might be one on the next page to put it into, but it's just the definitions. They are from the book. The amplitude of the graph of each function is half the difference of the maximum value and the minimum value. I don't like think about amplitude taking the whole distance and dividing it in half. I just like say how far up and how far down from the midline. But that's what the amplitude is, how high and how low from the middle. And then each function is periodic, which means that the graph has a repeating pattern. The shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called the period. So, like I said, these graphs have a period of 2 pi, but we're going to change that. So when we go to graph, there will be transformations on it. Today, we're only going to do amplitude and period transformations. That's all we're going to do today is amplitude and period transformations. If I take a graph that looks like this, and I have a new graph that looks like, whoop, that wasn't good. What do you think happened from the blue one to the red one? It is a kind of stretch.
Vertical.
That's a vertical stretch. And yes, the amplitude increased. Okay? Or if I have a graph that looked like this, I'm not going to be able to put it right on top of it, I'll just put it right underneath it. And then my new graph looks like this. I'm taking this curve and I'm going like this. Horizontal shrink. Because I'm taking it and horizontally going.
So if there's more waves,
If it's more wave, it'll be a horizontal shrink.
longer.
There could even be another one that's like, and that would be a horizontal stretch. There could also be one of these that is lower. Well, I can't do it on top of it, but there could be a vertical shrink. Okay, so that's what we're doing today, stretches and shrinks. All right, I've made tables. We did stuff with tables before. Just because I have all these boxes in the table, we're not going to always use every single box, especially just to start. But I gave you the same table for every single question. The first thing that you want to do is figure out which parent function it is. So they tell you in the equation, our parent function is sine x. And our new equation is 4 sine x. Okay? So the first thing I'm going to do is I'm going to write down the key points that we wrote down for sine. The x key points are going to be the same for sine and cosine. They're always going to be the same. The x key points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. They're the quadrantals. Every time. Those are the key points. For sine, if you can remember what it starts at, you could probably figure out the rest of them. So for sine, what's it always start at? It starts at 0. And then it goes from 0 up to 1 to 0 to -1 to 0. So those key points would be something you need to know. And after doing a bunch of practice, you should know them. Okay? Then you're going to answer this question. What does a 4 multiplied by the function do? Does a 4 multiplied by the function do? So it is a So this does say describe the graph as a transformation. So we're going to write down vertical stretch by a factor of 4. And then in our chart, you said it affects the y, so we go to the y side and we multiply by 4. Just the y values. We've done this before, a lot. Remember when we change the y values, then we don't graph both. We just graph the new y's with the old x's, right? I remember doing this stuff before, so don't graph those. Let's graph these ordered pairs. 0, 0. This is a different graph than I had on the original example, so just look carefully at what it's telling us that we're counting by. Next one is pi over 2, 4. Then pi 0, 3 pi over 2, -4, 2 pi 0. So what I just graphed is one cycle. So what is my period? What is it?
2 pi.
2 pi. And my amplitude is, it's always positive 4. And we're going to connect those with a smooth curve. But then you're going to continue the pattern through your graph. You're going to continue it. So the last part is, can you follow a pattern? So continue the pattern. Okay, when you got that one and you got all your information down, your amplitude, your period, your vertical stretch by factor of 4, turn the page. And I have changed the equation on the next page, so don't just jump right in. You do not want to do the one that's there. It's awful. I changed it. Okay, so I changed the equation to be 1/2 cosine 2x. I just screwed up the pi. So I changed it to be 1/2 cosine 2x. I just screwed up the pi. 1/2 cosine 2x. 1/2 cosine 2x. Okay. We're going to start with our key points. The x's are always the same. 0, pi over 2, pi. 3 pi over 2, 2 pi. Cosine y values start at 1, and they go to 0, -1, 0, 1. If you don't know that, you have it in your notes on the first page where we did cosine. Then we're going to look at our transformations. So we have a 1/2 in front. What does it mean if it's in front? It's vertical, but it's a half. Vertical shrink by factor of 1/2. So I'll take my y values and multiply by half. And we have another transformation in this one. So we have a number in front of the x, and if it's something that's with the x, remember the x side is always opposite. Remember the x's, we always do the opposite. So where it says 2x, that actually means divide by 2 or multiply by 1/2. You can do whatever's easier for you, either divide by 2 or multiply by half.
So what would that transformation be called?
So this is going to be a horizontal shrink by a factor of a half. Okay, so I showed you that before. When we have a horizontal shrink, you're going to take it and you're going to shrink it horizontally. That means there's going to be more of these up and downs in the same distance that there was before. All right, so I'm going to take each of my x's and I'm going to multiply by half. So 0. And then when I take pi over 2, and I'm just going to do this off to the side so you can see the work, pi over 2, and I multiply that by a half, multiply straight across, I get pi over 4. I take pi and I multiply by half, so pi over 2. And I take 3 pi over 2, and I multiply by 1/2. And I go straight across, and I get 3 pi over 4. And then 2 pi multiplied by half is just pi. So we're going to be graphing the x's that are in blue, the y's that are in red. We're graphing the transformed x's and y's, not the original ones in the center. So 0, 0. Nope, just kidding. 0, 1/2. And then 1/4. So I don't have 1/4 on this graph. Where would 1/4 be? In the middle of 0 and pi over 2, right? It's going to be exactly in the middle, so you have to think about that. So it's at 1 pi over 4 at 0. And then pi over 2 is negative 1/2. And then 3 pi over 4 I don't have, but that's exactly in the middle. And then at pi, it's at positive 1/2. So this is one cycle. But you have to continue that cycle. Yes. Awesome.
Where did you put the 1/4? Like the 0, 1/4? Or is that supposed to be 1/2?
Where are you looking?
On the y-axis. It's supposed to be
Right here?
never mind.
Point.
No, like, you said 1/4, that's supposed to be 1/2.
That's half, yeah. It's right here? Yeah, half. Did I say 1/4?
You said 1/4 or something.
I think I was talking about this one. Is that pi over 4? Okay, so this is one cycle. It has that classic cosine shape, which is like a valley. We do have to continue it through the graph. And I apologize when I'm standing right in front of it. But you see how my sleeves always like graph on their own. I have to stand right in front of it to do a good job. I'm just gonna make this in a different color so you can definitely see mine first. Okay, so we wrote down our transformations, we made our key points, we graphed it, and then we have to say what our amplitude and our period are. So the amplitude is how high and how low above the midline. Here's my midline, it hasn't changed yet. So we're going up 1/2 and down 1/2, so our amplitude is 1/2. And then our period is how long horizontally is one cycle. So I kept my one cycle in blue and I did everything else in green. How long is one cycle? To get that number without looking at the graph, you always take 2 pi and then you do what you did to the x's, divide by 2 or multiply by 1/2. That's going to give you that number every single time. Pi. So whatever you did to the x's, whatever that stretch or shrink was, that's going to give you the period.
So if there's no stretch or shrink to the x-axis, then it's just going to be 2 pi.
Every single time unless there's a number in front of the x in the equation. That's what will change the period. All right, I'm not going to do all of the rest of them. I want to pick, let's see. I want to do this one. Number 3. Oh, because I changed it also. Number 3, g of x, 2 sine 4x. Let's talk about transformation first. What does the 2 do? It's going to be a vertical stretch by a factor of 2. That means we're going to take our y's and multiply by 2. And then the 4 that is next to the x, the 4 that is next to the x is a horizontal something. So if it's a 4, that means I'm going to do what to the x values? Am I going to multiply by 4 if it's x? I'm going to divide by 4 or multiply by 1/4. It's up to you if you divide by 4 or multiply by 1/4. Remember, they're the same thing. So that is a horizontal what if I multiply by a 4?
Shrink.
Shrink. We're going to put in our key points, and we look, and this one is sine. Oh, it doesn't matter what it is. So the x's are always the same. But it matters for the y values. This one's sine, and sine starts at 0. So 0, 1, 0, -1, 0. We multiply those by 2. And then the x side, we're multiplying each of them by a 4, or dividing by 4. So the first one's 0. But for this one, if you need to do work off to the side, I'm going to be doing pi over 2, multiply that by a 4. So we go straight across, and we get pi over 8. And then I take 1/4 of pi, so pi over 4. And then 3 pi over 2, multiplied by 1/4, is 3 pi over 8. And then 2 pi, multiplied by 1 over 4. And reduce the 2 over 4, and we get pi over 2. And then we go and we plot these. Zero, 0. All right, pi over 8. I don't really know what that is on my graph exactly. Pi over 4. It's exactly in between pi over 2 and 0. So pi over 4, I can graph. 3 pi over 8, not sure yet, but pi over 2 is on my graph. Pi over 2 is 0. Okay, so pi over 8 has to be exactly in between 0 and pi over 4. It's got to be halfway in between. So my pi over 8 at 2 is about here, and at -2, there. So I've got my complete cycle right there. So that's one cycle. Let's write our period while we're at it. What is one complete cycle?
Pi over 2.
So you could take 2 pi and you could divide it by 4. And you're going to get pi over 2 for your period. Our amplitude is 2. Okay, all you have to do now is continue the pattern. If you do 4 complete cycles on positives and negatives, and there's still room, I don't think you need to keep going. Okay, if you do like 8 total complete cycles, I think that's plenty. If they're squished in so much, I'm okay with you stopping after 4 complete cycles on the positives and negatives. You have to have positives and negatives. I'm okay with that. Spend all your days just connecting dots, right? Unless you want to. Okay, just look at the last one. So I'm going to show you what to do if there's a fraction. I don't know if we do all the steps for the last one, but I want to get you started on this one. So it's cosine. the x values always start the same, but cosine starts on the y at 1. That's not the correct. And then cosine, if it starts at 1, it goes to 0, then -1, 0, 1. Here we have a 1/3 in front, so you're going to multiply your y's by 1/3. That means we have a vertical shrink with factor of 1/3. The x's that I'm more concerned about. So there's a 1/2 in front of the x's. So instead of multiplying by a half, what do we do to the x's? Yeah. Instead of multiplying by a half, we can divide by a half. But instead of dividing by a half, multiply by 2. Following? You're going to do the opposite. So we're going to have 0, and then 2 times pi over 2 is pi. Then 2 pi. And then 3 pi. And then 4 pi. This is a horizontal what?
Stretch.
Factor of 2. And then we go to graph those, and we have 0, 0, not 0, 0, I read it wrong, sorry. 0, 1/3, pi, 0, 2 pi, -1/3, bless you, bless you. And then at that point, oops, at this point I'm like off the graph. So you just have to, I mean, you can go off the graph if you'd like, or you just have to continue the pattern the other way. You just show as much as you can of it. So this one will be at 0, this one will be at -1/3, this one will be at 0. Kind of messy. So this one was definitely a vertical shrink, and it's stretched out horizontally. What would be the period?
4 pi.
Yeah, 4 pi, and then our amplitude is 1/3. Okay, so you have the rest of the bell to work on that assignment you were already working on, and then I've only added 4 questions from the book for graphing. It was something else, and I've changed it. There's 4 questions, and I have tables and graph paper, so all you have to really do on here is write down the information. It's just 4 questions, so if you don't want to, take a picture of the book, you just write down the 4 equations really fast. The directions are to do exactly what we're doing. Write the transformation, write the amplitude, write the period, and graph it.